All right, whenever you first take the AP Chem test, what you're going to want to do is you're going to want to keep all these strategies in mind. You're going to want to make sure that everything is visible, so your units, all of your stoic, everything is visible. You're going to want to make sure that all your responses are short and simple if you have to write them out. You're going to want to do the easiest ones first, obviously go for the low-hanging fruit, and then if it comes down to it and you'll have time, guess if you have to. So the question that we're doing is going to be the 2015 AP Chem question 2. This is a release question, so you can probably get this online if you wanted to, and I know the 2014 we have one of those too. So that's what we're going to do. Yeah, great. Okay. The first part of it's going to be asking you to find the number of moles of C2H4 that was actually produced from our gas collection tube. So basically what this explains on here is that you have 35.7 torr, which was our vapor pressure up here, and that's going to be vapor pressure of water. So you're finding just the gas pressure of ethene so that you can use your PV equals nRT to figure out the number of moles. And remember, that's what we're asking. We're being asked how much was actually produced in moles. So all that this is doing right here is it's taking our 35.7 torr and converting it into ATM, because our PV equals nRT functions in ATM, and we're given the units ATM. So just remember, the most important thing that you're going to want to do is to make sure that your units are all being used. So as you can see on here, like I said, that we're given is an ATM. So what they did here is they basically just took this water vapor and they subtracted it, because look, P total. So as you can see right here, our pressure of ethene is going to be equal to 0.775. Whenever you're solving this and you do it on your own, I'd recommend that you do it on your own just to see, and then you can kind of compare. But the best way to do this is, notice how they're keeping all of their units. Units equal good grade. If you do units and you do everything right, you're not going to need to have to go back and double check your math, because everything's in front of you. You know you're using the right numbers because all the units will match up and cancel out. So ATM with ATM equals ATM. You need that pressure of ethene to make sure you have ATM, and then they just basically set up PV equals nRT, rearranged it for N, and notice how they did everything. And up here, the best thing for you to do is to just use your equation. Then they rearranged it. They set your P, which is going to be your pressure, then the liters that they gave you, which is up here. Where is it? Right here. Right here. Then they gave you your R, which is your constant. Remember, look at your units. ATM over ATM. You're going to want to use this one. There is one for torr. There is a conversion for torr for R. Don't use it. Just don't. You have moles on top. You have, and that's what you're solving for. This is the inverse, so it really means moles is above, and that's why we get our answer in moles. And then, of course, we're using K, which is right here. So that's how you're going to find your moles for the first part. Just remember, if you look on here, you can see that this says 1 point is earned for finding the pressure. The pressure needs to be an ATM. So your units, that's what's important. This part right here is asking you for the number of moles. Remember, this is going to be your equation up here, this PV equals nRT. Again, units. Just make sure everything is correct, make sure everything's on the page, and like I said, you can logically follow everything. And these AP graders, that's what they're looking for. They're looking for your work. They're also looking for your answer, but a lot of these questions have points just for work. So even if you don't know the right answer, as long as you set up everything correctly, you should be getting some points. So you can't really lose, even if you don't know. Okay. The pressure that would be produced from the dehydration reaction went to completions. Next part, all you got to do is take your ethanol, and you're going to take your grams, and all you're going to do is just use stoic to figure out how many moles were produced. That's very simple. It's just taking 1 mole of ethanol equals 1 mole of ethene, so we're just doing molar conversions. But notice, G on the bottom, G on the bottom, G on the top. Mole on the bottom, mole on top. Bottom, top. And that just leaves you with moles, and that's what you're given. So again, keep all your units, make sure that you're putting what is what. Notice how this right here is going to be ethanol, this is going to be ethanol, and we end up with ethene, and that's how we know that we're actually solving for ethene like they, where is it? Yeah, we're solving for ethene like they asked. Notice the point goes to figuring out the correct number of ethene. Calculate the percent yield. Percent yield is just going to be your actual yield over your theoretical times 100. Remember, your actual was produced up here. It says actually, and this one right here said what would be. So then you just kind of put them over each other. You can figure out percentage. Again, mole over mole, yield over yield. Everything works out. For thermo, you're just going to want to remember your equations, and a lot of these are just remembering your equations. If you know them, and you're given most of them, so as long as you remember your equations, or at least you know what to relate to, or where to look, you'll be able to find what you need. kg over mole, and this is going to be a little bit tricky because some of these ones are, whenever you're dealing with delta G, they're going to, some units are going to be in kg, some units are just going to be in joules. So anyway, they just did the reaction right here. They did their H, T, your delta S, and they got 8 kilojoules. And then it asks you in here, justify your answer and include a calculation of delta G. What you can do for that and how you justify it is delta G is greater than 0, so it's actually going to happen. And this is what they say. Basically, if you just explain delta G is bigger and it's going to be spontaneous, that's enough justification as it is. And remember, keep this justification short. Like, you can do it mathematical, or you can just use words or just sentences. Doesn't matter. Just make sure that you're saying it's going to be spontaneous and delta G is going to be negative. Or positive, actually. Alrighty, so now it's going to ask us for the Lewis dot structure. Again, this is just going to be basic knowledge that you know. Generally, what you can do to kind of figure out how you're going to do Lewis dot is you're going to look at their own example. Because the way I normally do Lewis dot is going to be with 2 electrons like that coming outward. Of course, they didn't say to do that. They want it to look like this, just like over here. And I'm pretty sure it just depends. I personally would count the way I do it, but the AP test graders are going to go off of what this the example looks like, and this is the example. So whenever they ask you to make this, just remember that H bonds with C. Your OH is going to be off to the side, and generally these are written the way that they're going to look. So you can kind of figure out from context clues, and then if you really wanted to, you can balance out and go, okay, 1, 2, 3, 4, 5, 6, 7, 8. This one has a full octet. It's going to be good. This one has its full has a full electron shell of 2, since hydrogen only has 1. 1, 2, 3, 4, 5, 6, 7, 8. This one has 8. This one has 8. So make sure to check and balance everything, but if you follow the way that the example gives you, you should be able to figure it out pretty easily. And this question really shouldn't be a problem unless you can't balance octets very easily, in which case, again, if you follow the example on here and you make sure to check that each one of them have an octet, you should be fine. They were giving points out for just the correct diagram, so, you know. And then finally we have, what is the approximate value of COH bond angle? Okay, bond angles are tricky because you just need to know them. That's the whole thing about them. You either know bond angles or you don't. And generally what I did whenever I took this was I guessed. A lot of times whenever you have just 3 different elements on here, it's going to be kind of a bent shape. And look at the form that this O right here takes. Whenever there are 2 on each side and then there's 2 different elements on each side, I think of it as it should be straight, but then I remembered, and you're just going to have to remember this, that whenever you have 2 different pairs and then you have 2 different elements on the sides, it actually bends. So instead of looking like this, it's going to kind of look like that. So just remember that bent is not going to be a just straight line because these two balance each other out. It's really going to be bent. And learn what the different shapes are, learn what the corresponding bond angles are, and you should be fine. Do notice that they have kind of a range because different people write different things. I was taught 109.5. They're saying on here you can go all the way down to 100 and all the way up to 115. So it just depends on the person and how you learn it. But personally, I always do 109.5. Study these. You're going to need to know them. This is one of those, again, this is just one of those things you either know or you don't. You can't really check yourself. It's just how well you trust yourself. And if you don't know, choose 109.5 because I've noticed the majority of them